This video tutorial is the continuation or part 2 of Physical Properties of Solutions, General Chemistry 2 Self-Learning Package, Quarter 1, Week 3. We will start with molarity, with a symbol of capital letter M. Is a useful concentration unit for many applications in chemistry. Molarity is defined as the number of moles of solute in exactly 1 liter of the solution. It has the formula of M is equal to number of moles of solute divided by volume in liters of solution. Molarity has a unit of mole per liter. MOL is the abbreviation of mole. Let's go to sample problem number 1. You have 3.50 liters of solution that contains 90.0 grams of sodium chloride or NaCl. What is the molarity of that solution? Again, we need to write the given, the required, the formula, and then the solution. So from the problem, we can get the given. 3.50 liters is the solution volume or volume of solution. 90.0 grams of sodium is the mass of solute. Now remember that solution has two components, the solute and the solvent. The solute is present in lesser amount and the solvent is present in greater amount. In this case, 90.0 grams of sodium chloride is present in lesser amount in a 3.50 liters of solution. Required molarity of the solution, which is NaCl solution, and we have the formula. Then the solution. Step 1. The solute is described in the problem by mass, not the amount in moles. You need one conversion, grams to moles, of solute using the inverted molar mass of sodium chloride to arrive at your answer. So, from grams of solute to number of moles of solute, then we can get the molarity. So the formula is gram sodium chloride times 1 mole sodium chloride divided by gram sodium chloride. This is the molar mass, which is equal to mole sodium chloride. You will need the molar mass of sodium chloride, which is 58.44 grams per mole. 58 grams per mole will also be okay to use. So mole sodium chloride is equal to 90.0 grams sodium chloride times 1 mole sodium chloride divided by 58.44 grams of sodium chloride. We put the mole on top on the numerator and the grams in the denominator so that we can cancel gram sodium chloride, and what is left is mole sodium chloride. Now, if we divide this 90.0 divided by 58.44, the answer is like this. And how do we know where do we round off the answer? So just count the number of significant figures here. The least significant figures is the one that we will use to round off the final answer. So it's here 1, 2, 3 significant figures, and here we have 4 significant figures. So the least significant figure is 3, so we will round this off into 3 significant figures. 1, 2, 3. That is why the answer is 1.54 mole sodium chloride. Next, step 2. Solve for the molarity. So we have the formula. And The mole of solute, 1.54 moles sodium chloride, and the given earlier, the liter of solution is 3.50 liter of solution. So 1.54 divided by 3.50, the answer is 0.44. Now, we follow again what we did above. This is three significant figures here. Three significant figures. That means the list is three significant figures. So we will round off our answer into three significant figures. When you divide 1.54 with 3.50, the answer is 0.44. These are only two. These two only have, or this three here, or this answer here, have two significant figures. How do we make it into three significant figures? Just by adding 0. So significant figures 1, 2, 3. I will not explain how to determine the significant figures here because I guess you know that already. So the final answer is 1, 2, 3 molar sodium chloride. M, capital letter M, remember, is mole per liter. Sample problem number 2. You have 0.8 liter of a 0.5 molar HCl solution. How many moles of HCl does this solution contain? Again, we need to write the given. So 0.8 liters volume of solution, 0.5 m HCl is concentration of solution, required moles of HCl. Formula, and then we go to the solution. The molarity indicates the moles of solute that are in 1 liter of solution. Given the volume of the solution, the number of moles of solute can then be found. So, from this formula, moles of solute, that is the mole of HCl, multiplied by here m times volume in liters of solution. So we did just cross multiply. Number of moles here is equal to m times the liter of solution. So moles of HCl is equal to, we have 0.5 m or 0.5 molars. Remember that 0.5 molar is equal to 0.5 moles per liter or per 1 liter of solution times the liter of solution, and the problem is 0.8 liters of solution. So liters of solution and liters here of solution cancelled out. What is left is mole of HCl, 0.4 mole HCl. So we have the least significant figure here. So this one is 5 significant figure, this is 5, and this is 2. So the least significant figure is 1, so that's why the answer is contains only one significant figure, 0.4 mole HCl. Next, percent concentration. Concentration is equal to amount of solute divided by amount of solution. We have A, the mass percent, which has the symbol of percent m over m, mass percent. Concentration of a solution describes the mass of the solute in every 100 gram of solution. The mass in grams of the solution is the sum of the mass of solute and the mass of the solvent. Okay, if it is percent mass, these are all mass solute, mass solvent times 100. Sample problem number 1. Suppose we prepared a solution by mixing 8.00 grams KCl with 42.00 grams water. What is the mass percent of the solution, or percent by mass of the solution? Given mass of solute is 8.0 grams KCl, mass of solvent 42.00 gram water. Mass of solution is we add 8.0 grams of potassium chloride and 42.00 grams of water. 8 plus 42 is equal to 50.00 grams. Required mass percent, or percent M over M. The formula K and the solution. So percent M over M is equal to the mass of solute is 8.0 grams divided by 50.0 grams times 100 is equal to 16%. Okay, why it is 50 divided by 50? Because this is the mass of solution. Okay, that is 8 plus 42. And then volume percent is the volume of the solute in 100 ml of solution, and the industry wine label that reads 12% V over V, or 12% by volume, means 12 ml alcohol in 100 ml of wine. So the formula is volume percent V over V, volume solute, volume solution, volume percent, volume times 100. In industry, a rum that reads 80 proof is 40% by volume alcohol. The higher the proof, the higher the alcohol content. Alcohol proof is twice the volume percentage of ethanol in alcoholic beverage. Sample problem. How many milliliters of a 5.75% B over V ethanol solution can be prepared from 2.25 ml ethanol? So, given percent B over V of ethanol solution is 5.75%. Volume of solute is equal to 2.25 ml. Required volume of solution in ml. Formula and the solution. Use the inverted percent V over V to solve for the volume of solution. So, here, 5.75 ml ethanol, that is the volume percent, is equal to 2.25 ml ethanol, that is the volume of solute, divided times 100 divided by volume of solution, which is the required. So we put the volume of solution here on the left side of the equation, and the 5.75 ml of ethanol will be in the denominator on the right side of the equation. So just like this, if we cross multiply this one, volume of solution multiplied by volume percent V over V. So there is 5.75 here. So the volume of solution will be here, and then the volume percent V over V will transfer in the denominator. Okay, so volume of solution is equal to 2.25 ml of ethanol times 100 ml of solution. In 100 ml of solution, there are 5.75 ml of ethanol. Okay, So this ethanol transferred here in the denominator. So ml ethanol cancelled. What is left is ml of solution. So 2.25 times 100 divided by 5.75 is equal to 39.1 ml solution. Next, mass volume percent m over v. The m over v percent indicates the mass or the grams of a substance that can contain an 100 ml of solution. For example, 5% m over v glucose solution contains 5 grams of glucose in 100 ml of solution. The volume of solution represents the combination of glucose and water. Sample problem. How many grams of sodium hydroxide are needed to prepare 125 ml of a 8.80% m over v sodium hydroxide solution? Given volume of solution is here 125 ml. Percent m over v is 8.80 or 80.80 grams sodium hydroxide per 100 ml of solution. Required mass of sodium hydroxide. Formula: percent m over v is equal to mass solute over volume of solution times 100. It's the same process that here we cross multiply. So mass of sodium hydroxide, this will include the 100 times 100 and then cross multiply 8.80 grams of sodium hydroxide times 125 ml of solution. And then mass of sodium hydroxide, this one will transfer in the denominator. So there are 8.80 grams of sodium chloride in 100 grams of solution. So ml of solution and ml of solution cancelled. What is left is gram sodium hydroxide. So 125 times 8.80 divided by 100 is equal to 11.0 grams sodium hydroxide.